Hi there, this is Derivative 11 examples, and I'm just going to walk you through a few hyperbolic functions and their derivatives. So let's first start off with y equals hyperbolic tan of 4x. And remember, that's going to include the chain rule. So you're going to get y prime is going to equal hyperbolic tan. The derivative of that is going to be secant h squared of 4x multiplied by the derivative of what was inside the parentheses. Hence the chain rule, 4. The total result is 4 secant h squared of 4x. That's your total. Moving on, let's try another one. Y equals x cosine h of x. Now this looks like it's going to include the product rule. Derivative of the first is just 1 times the second plus the first, which is x, times derivative of the second, which is just going to be sine h x. Therefore, when we simplify that out, y prime is going to equal cosine h of x plus x sine h of x. Very nice. Let's move on to the next one. You have y equals sine h squared of x. Notice that this is actually going to require the chain rule once again, because this is, you have that squared of the sine, so you have to bring that 2 down in front. So y prime is what's actually going to equal 2 times what's sine h of x. And we would do the same thing. I mean, if it was y equals x squared, you would bring it down to 2. The y prime would equal 2y or 2x, and then times the derivative of x, which is just 1. So you have 2 times sine, then times the derivative of what was inside the parentheses, which is sine x, which turns into cosine x. So you'll notice it gets pretty messy real quick. Okay. Let's move on over. Y equals e to the x, secant h of the x. As it goes to, notice you're going to have to use a product rule, and it doesn't look like the chain rule is going to make much of an effect here. But product rule definitely will. So y prime is derivative of the first, which is just e to the x, times secant h of x, plus the first one, which is just e to the x, times the derivative of the second, which is much messier, secant h x, times tan h x, so you'll notice, I mean, I'll do it for you. Just don't get used to it. Pull out the e to the x for everything. That's what I would do, is pull out e to the x, and I would also pull out secant h of x. Therefore, when we get the results here, we should have 1 minus tan h of the x. And that should be our answer. Alright, let's do one last one. natural log of sine h of x. Well, you're going to be using the log rules and the chain rule and a whole mess of rules. So the log, you have to do the derivative of log, so is equal 1 over x. X is sine h in this case, so there you go. That's the first part. And derivative of what's inside the parentheses, which is cosine hx. Well, when you multiply those two together, that's actually going to equal cosine over sine, which is cotangent of x. Very cool, huh? And I could probably fit one more in here without making it too bad. Let's do tan h of e to the x. Y prime will then equal, you just have to do the derivative of first tan h, so that will be equal secant h squared of e to the x. Then derivative of what was inside, which is you're doing the derivative of the inside, which is e to the x. So that should equal e to the x secant h squared e to the x. Very handy dandy. And I hope you really enjoyed all the sample examples, and I hope you enjoyed the entire series, and I hope to see you guys in another video. Have a good one.